length of a circular arc. In a circle of radius r, the length s of an arc that subtends a central angle of theta radians is s equals r theta. Now typically, we're going to be solving for theta, so we rearrange it to be theta equals s over r. And please note that theta is measured in radians. So when you look at a circle, it doesn't have to be the unit circle, it can be. You're going to have r, and this angle is going to be 1 rad. If you double it, your angle is going to be 2 rad. Find the length of an arc of a circle with radius 10 meters that subtends a central angle of 30 degrees. So we're given an angle in degrees. So we need this in radians. So we can compute this to be 30 degrees times pi over 180. This goes to pi over 6, which we actually computed before. So now we're going to take our pi over 6. And our angle, remember our angle name is theta. So theta equals pi over 6. Find the arc length. So we want to find s. We're going to plug this into the equation. S equals r theta. And we know r is 10. So s equals 10 times pi over 6. And we end up getting 5 pi over 3. And 10 was in meters, so this is in meters. A central angle theta in a circle of radius 4 meters is subtended by an arc of length 6. Find the measure of theta in radians. So now we have a radius 4 meters, arc length s is 6, so we want to find theta. Theta equals s over r. So we plug it in, 6m over 4m. The meters are going to cancel out. 6 over 4 goes to 3 over 2. And because we're talking about the measure of theta, this is in radians. So theta is 3 over 2 rad. Circular motion, linear speed, is the rate at which the distance traveled is changing, distance over time. Angular speed, change at which the central angle theta is changing. Suppose a point moves along a circle of radius r and the ray from the center of the circle to the point traverses theta radians in time t. Let s equal r theta be the distance the point travels in time t. The speed of the object is given by angular speed omega equals theta over time, and linear speed is given by nu, and u equals the arc length over time. A boy rotates a stone in a 3-foot long sling at the rate of 15 revolutions every 10 seconds. Find the angular and the linear velocities of the stone. So in 10 seconds, the angle theta changes by 15 times 2 pi, 15 revolutions, and it takes 2 pi for a revolution, but we don't know how big of a revolution, so times r, oops, I'm sorry, r is not into play yet, and so that gives us 30 pi radians. So omega equals theta over time. So we get 30 pi radians divided by 10 seconds. So our answer turns to be 3 pi radians per second. So we have now found our angular speed. So to find our linear speed, the distance traveled by the stone in 10 seconds is s, because we're talking arc length, is 15 times 2 pi r, because radius matters. And we know our radius is 3, so we substitute this in. 15 times 2 times 2 pi times 3, and this gives us 90 pi feet for s. So we now plug this into nu, and we get arc length divided by time. This is 90 pi feet over 10 seconds. It simplifies down to 9 pi feet per second. So the relationship between linear and angular speed is given by the formula nu equals radius times omega.